Hi, this is Charlie. Welcome to our next lecture. Let me share my screen and we can get started. Hopefully everybody's had a great week and is ready to work on database systems. Okay, that's our next module. Okay, so module three, we know the routine, right? There's a quiz and there's assignment, and you also have to discuss. There's a discussion. Okay, I will cover the assignment at the end. I do want to jump into the lecture. I think I'll spend more time actually trying to help with the assignment than doing the actual lecture. Okay, database systems. So we're going to cover database fundamentals, the relational model, a little bit of the object-oriented databases, not too much. I don't really care about them. Maintaining database integrity, that's important. Traditional file structures, very little discussion on data mining and social impact of database technology, okay? Database fundamentals. It's a collection of data that is multidimensional in the sense that internal links between its entries make the information accessible from a variety of perspectives, right? So there's a relationship between the data, okay? File versus a database. Here's a file-oriented system, right? Customer records, there might be payroll records, employee records, and so forth. If you notice, there was no real relationship between like customer records, payroll records, and so forth. All the circles at the top, right? So now if we come here, if you notice, there are double arrows to the integrated database, so therefore there are relationships between each box. That's what they're just depicting here, okay? So there's a relationship between the purchasing department, the personnel department, the marketing department, and so forth. It's all integrated. And we'll see an example of this later on in the lecture. Roles of schemas. Schema, it's a description of the structure of the database, right? Used by the database software to maintain the database. A subschema, a description only a portion of that database, uh, pertinent to particular users' needs. Used to prevent sensitive data from being accessed by unauthorized personnel. Okay, so, when you're talking about databases and me being a cybersecurity guy, you always have to say, well, how do you keep this data secure from folks who have access and those who are not authorized to have access? You got to protect the data. Database management systems is software layer that manipulates the database uh, in response to requests from applications, right? So that's the system. A distributed database, a database stored on multiple machines, okay? Uh, right? So you would do that for a redundancy, also for performance. Data independence, the ability to change the organization of a database without changing the application software that it uses, right? So so the software doesn't need to change, just the database would need to change, right? But that's not 100% true if you really think about it. If you change the structure of the database, if you change the tables, depending on the change, if you change the tables, then the software would have to change, right? Fields in the table. But that's good enough for our class, right? Conceptual layers of a database implementation. You have a user starting from the left, and then you have some application software. I don't know. It could be, for example, it could be an SAP Enterprise Resource Package, ERP, right? That's pretty popular. And then this would make requests to a database management system, right? So maybe we'd like to bring up all the inventory records. Okay, and so that'd be passed to the database, and then it would communicate with the actual database. Okay, to get to get the to get the uh, data. Now, if you notice, the application software does not have an arrow directly related to the actual database, right? It has to go through the database management system. That's for several reasons. Because first of all, it manages the database. Secondly, there's also a security layer here as well. And I think even in the application software, I mean, there's also security as well. So, Database models, it's a conceptual view of a database. There's a relational database model, which we'll spend most of our time on, and there's object-oriented database models. I don't think they're as popular, to be honest with you. They're not, I don't see them used as much. There's much more relational databases used than many more of them than the object-oriented. The relational model, it's a rectangular table, has a column and has a row. The attributes a column, tuples a row, okay? And we're going to see examples of this. So here's an example. Here's a table that has employee ID, name, address, and social security number, right? So as you see, every row contains each one of those fields, and a column is specific, right? So the column for name only contains names. Okay. Issues of relational database design. Avoid multiple concepts within one relation, right? They call this database normalization. Can lead to redundant data. You're trying to reduce the redundant data by the schema. Deleting a tuple could also delete necessary but unrelated information, so you have to be careful. Improving relational database design, decomposition, dividing the columns of relation into two or more relations. Okay, lossless or non-lossless decomposition, a correct decomposition that does not lose any information. And we're going to see an example soon, okay? Because this could be confusing if you don't see an example. A relation containing redundancy. Okay, here's one with employee ID, the name, the address, social security number, job ID, and so forth. And as you can see, uh, Joe Baker is in here a few times. For the to the left side, that's the different. That's the first two rows, and then there's the redundancy. So there's a way that we can design this that it doesn't have to have the redundancy. Uh, So here's again, here's a employee column. Let's focus on employee column. Uh, I mean here's the employee relation, employee ID, the name, the address, and social security number. And here's the job relation, okay? And so it has the job information, the job ID, and the job title, right? So as you could see, employee ID 2X 25X15, uh, job ID, department. Okay, you cannot see it in there. Okay, and then here's employee ID. Here's assignment, the employee ID, which you would get from this relationship, the employee, and then the job ID you would get from this relation or table, I'll call it, right? And then the start date and end date. So the redundancy was removed. Uh, Lots of redundancy removed. And this is really called normalizing the database. And there's all different levels, and that's beyond this course. Um, Relational database management systems, usually I see at universities they have two courses specific to relational database management systems, usually database management systems 1 and 2. And so in this course, we're at a much higher level. Okay. Find the departments in which employee 23Y34 has worked. Okay. And here's an example. Here's employee ID 23Y324. His job ID is, again, working from the bottom up, 25 S25X and S26Z. And it looks like they were secretaries, secretary job. Uh, there's a skill code. I know what that is. And if you notice the department, so he worked in two different departments. Okay. He was terminated in one. I don't know what then and termination date. Maybe he's working in the other. But as you can see, that's the relation. Original relation containing employees' jobs and departments were broken out into employee ID with job title, and department. Okay. Relational operations. There's select. You can choose rows. Project. Choose columns from those rows. Join. You can assemble information from two or more relations. The select operation. So here, again, we have our employee ID, name, address, social security number, and here's select from employee, where the employee ID here on the left is 34Y70. So that would be Cheryl H. Clark. Her address would be 56563 Downtown Avenue, and there's a social security number. Okay. So as you can see, what you have to be very careful about in with databases, and it's beyond this course, is that when you have PII data, right, personal information, it's very you gotta be protected. It probably should be obfuscated in some way. It probably shouldn't just exist like that in a table. But for this course, we're okay with it. Like I said, in the other courses, you would go over that. So here's the new relation I just described. Okay. Okay. The project operation. Project name and address from employee. The name and the address. So there you go. Mail relation. So there's the name and the address. I guess they're calling it mail relations. Maybe they're gonna mail something out to the person, right? So, but you could also okay, so we're not into SQL yet. The join operation. Join A and B where A dot W equals B dot X. Okay, so what we're doing is we're describing at a higher level SQL, structured query language. We're going to get to that in a minute. And that's what will be on the homework. So here's relation A with VW. Here's relation B with XYZ. So join A and B, that relation A and B, where A dot W equals B dot X. So 2. A dot W is 2, and the only place where B dot X is 2 right here, right? So we will get R22MQ, relation C. But there's more than one entry. There's also 4. If there's a 4 and here's a 4 here, the WX, so therefore you see T44. The T44 is because there's also 4s. There's 2 4s. There's 1 4 here, 1 4 there that matches the W. That's why you see three tuples, okay? 3 rows. Another example of the join. Join A and B, okay, where AW is less than BW. And here would be other results. So let's see. So 2 is less than 4. So you would get the first row and R2 4DE, right? But you also get another row because 2 is less than 5. So you get R2 5TF. And then the last row, 4 is less than 5. So T4 5TF. That's the last row you'll see in there. Now, if you go to 6, 6 is greater than all the X's here. So there's no join for that. Okay. And it's important to know because some of the problems on the homework will require a join. Okay, here's an example of the join. Join assignment and job. So assignment and job, where assignment job ID equals job ID. So S25X, S25X. Okay, so there's more than we don't have the complete tables, but here would be the new relation and here would be the results, okay? Okay, like I said, this was a precursor to the structured query language, SQL. This is the language you use to query a relational database, to do your selects, to do your projections, to do your joins. It's a structured query language, and it's very simple, similar to what we just covered. And so there are insert operations, so you can insert into a table. There's updates. You can update a table or a relation. You can delete from the table. When I mean table, it's table or relation, and then you could select from the table. So here are some examples. Select employee ID department from assignment and job, where assignment that job ID equals job that job ID, and assignment termination date equals asterisk. So it has anything for termination date. Okay. Here's an example of insert into employee the values that must be employee ID 43212, the employee's name Sue A. Burt, their address, and I think this is a social security number, right? And so that's the format that you have to follow for inserting. Okay. Here's a delete from the employee table where the name equals G. Jerry Smith. Okay, update employee. Set the address. So again, this is a format they have to use for SQL. When you do an update, you put the table name employee, set address equals 1812 Napoleon Avenue, where name equals Joe E. Baker. So Joe E. Baker probably moved. And so now we're just setting a new address for that person. Okay, before I continue on there, I do recommend if you've never written SQL before, okay, and you want to, because I can't possibly cover all the options in SQL. It's impossible. Uh, you could go through these examples in W3 schools, okay? And they have many examples for selects, join. See, there's the join. Sorry about that. Uh, and so forth. So I recommend that if you haven't worked with SQL before, haven't done much database work, here would be a good place to practice and learn more about it. If you're comfortable with just the lecture, if you're comfortable doing the homework just from the lecture, then you can, if you don't have a lot of time, you could skip this. But if you're not comfortable with the homework, then I suggest going through this. If you have any questions, please let me know. Okay. So now we're on to object-oriented database, a database constructed by applying the object-oriented paradigm. Okay. I would say 20 years ago, this was a very hot topic in databases. It's kind of cooled off. It's not as hot. Each entity stored as an object, persistent object. Links indicated by relationships indicated by links between objects. Database management systems maintain inter-object links. So here's an example of objects, right? And here's an employee. He's assigned a job. An employee is assigned a job. So they have employees being assigned a job, okay? And they're showing that relationship there. No biggie, okay? And there are some advantages of object-oriented databases, matches design paradigm of object-oriented applications. That's one advantage. Intelligence can be built into attribute handlers, can handle exotic data types like multimedia. Uh, but the homework, you're not going to be working with object-oriented database. You'll be working relational. Okay, that would be like a database 2 course. Database 2. Okay, maintaining database integrity. This is very important, right? So transaction. A transaction is a sequence of operations that must all happen together, right? Like for example, transferring money between bank accounts. That's a transaction. So if part of that transaction failed, you'd have to roll back the transaction. Okay, you have to make sure the whole complete transaction is successful. And there are many examples that you could think of. Uh, Transaction log, it's a non-volatile record of each transaction's activities built before the transaction is allowed to execute. So it's the transaction log that keeps track of everything that's happening in the transaction. And so in case there's an error during that transaction, you could roll it back. Commit point, that's what I'm talking about. The point at which a transaction has been recorded in the log. Now the rollback, the process of undoing a transaction. Okay, so the The relational database management system actually has these logs and has to use these logging, and it's on the file system to keep track of this. Maintaining database continued, integrity continues, simultaneous access problems, incorrect summary problem, must update. So there could be simultaneous access problems. The database handles that. The relational database management system handles that. So let's say, for example, if you're trying to do an order and the inventory has to be adjusted and so forth, there'll be a lock on those tables until that transaction's completed. Then the next person can start that transaction. Locking again. Oh, locking. Here it is. Preventing others from accessing data being used by a transaction. There is a shared lock. When reading the data, if it's only you only need to read it, then it could be a shared lock. When the data is being altered, like alternate, updated, deleted, like for example, I give the example, the inventory has to be adjusted, then you need an exclusive lock. Here are some traditional file structures. Okay. A file whose sequential file, a file whose contents can only be read in order. I think we're used to that, right? So reader must be able to detect end of file. Data can be stored in logical records, sorted by a key field. It generally increases the speed of batch updates, right? So here's the structure of a simple employee file implemented as a text file, right? So this isn't a relational, this isn't an RDBMS anymore. This is just working with sequential files. Um, File consists of a sequence of blocks, each containing 31 characters. Okay, so an employee file, it's an employee file. So each one of these, each row contains the name and the employee's identification. That's what they're showing here. And here's a function for merging two sequential files. And I'll let you read that. Any question about that, let me know. I don't really care about that. Applying the merge algorithm to represent entire records. The particular indicates the value of the record's key field. Okay, so here they are merging. Index files. It's a list of key values and location of their associated records. Efficient way. It's efficient. Uh, to quickly identify the location of a desired record. Index is stored as a separate file. So the index file is much smaller, right? If you think of that employee example we just described, that had how many characters in it, right? So, but the index file could just be maybe on the last name. So it's much smaller. Therefore, you can, and it'll tell you where those records appear in the larger sequential file. So therefore, it can use the index, load a whole bunch of stuff, whole bunch of many more rows from the index file and find out exactly where the employee record is located from maybe from the last name. Okay, here's opening an index file. There's main memory. Index is transferred to main memory when the index file is open. Okay, so again, that's why the index is much smaller than the file. If you want to create an index that's almost the same size as the file, and then fields, then you've kind of defeating the purpose of the index, right? You're trying to keep it smaller. It makes it more efficient to in memory, and you may run out of memory. But now today, I'll be honest with you, with the cost of memory, now there are in-memory databases. One example is the HANA database, and that is with the use of compression. I think they get 10 times compression of the data, and the cheap cost of memory. They now put the whole database in memory to make it more make for quicker queries, quicker processing. Index stores is a separate file, right? And I've described that. Hash files. Each record has a key field. The storage space is divided into buckets. So you have to use a hash function. It computes a hash function is one way. It computes a bucket number for each key value. Each record is stored in a bucket corresponding to the hash of its key. Okay, here's the key field. Here's the ASCII reputation, equivalent base 10, remainder the binary for 4, the bucket number 3. Okay. And here they're giving it the rudiments of hashing. I don't think you're hash collisions in hashing. Again, the homework, no questions on hashing. Okay. I'm not sure about the quiz, but you guys are doing tremendous on the quizzes, tremendous grades. Collision, the case of two keys hashing to the same bucket's a major problem when the table is over 75% full and you're using hashing uh, to get to your data, right? Increase the number of buckets and rehash all the data. Okay, now we talk about data mining. The area of computer science that deals with discovering patterns and collections of data. This was very hot. I think it's still hot, but actually LLMs help you with that, right? Generative AI. A data warehouse is static data collection to be mined. A data cube, data represents from many perspectives to enable mining. And the reason why you do this, you're trying to discover patterns, glean some knowledge from this data, what's going on, right? From the data. Data mining strategy, class discrimination, cluster analysis. There's all different kinds of analysis. Outlier analysis, that's a good one. Where's the difference in the data? What does that mean? Sequential pattern analysis. Okay, social impacts of database technology. Massive amounts of personal data being collected. Almost everything that you click on the internet, that data is being collected. Even without your knowledge, and it's being sent all over the place. And we always hear about these data breaches, right? Data emergence produces more invasive information, right? So it's a privacy. If you remedies exist, legal remedies, negative publicity may be more effective. I wish there was a better remedy. I think we're beyond that point. They're collecting all your information. So that's what I had for the lecture. I didn't want to spend too much time in the lecture because I want to spend more time on the homework. Okay? Uh, for you to understand the homework. So, and what has to be done. Okay. Here's assignment 3. Okay, so where's assignment 3? Okay, so first of all, assignment 3, I do not want zip files. I don't want .sql files. I only want text files. And all you need to submit is the SQL statements that you're going to construct. You do not have to submit the results. So I think there are like 10 questions. So your text file should have 10 SQL statements in it. That's it. I can look at them right away, type the incorrect or correct. It'll make it easy for me grading. You'll get your grade back really quick. I don't have to scroll through tons of pages of results. So, okay, so let's see. I have the homework. Uh, where is this? Okay, let's do this. I don't know. Oh, it's right here. No, it isn't. Let's go here. So, oh, another thing too, before I start, there's a zip file that you need to download. So download that. That'll contain 3 um, SQL files, and I'm going to show that in a minute. And then there are database uh, systems. Let's click on this. I don't know what happened to it. Okay, so here's the homework. Okay, we could skip right to it. So we're going to use livesql.oracle.com. Okay, so uh, here it is. Here's free SQL. So I'm going to sign in. So, so you need to go create an account. It's a little slow. It was slow when I tried it before. Okay, of course this would, no, let me type it. Okay, and I put my password, so I'll sign in. Okay, so you'll get an I get email verification, okay? Um, I chose email verifications. So I should have my email up. Okay. Here's my email. Definitely not that. That was one earlier. What? There's an email verification. Let's see. It says it has been sent, so maybe you got to give it a minute, okay? Just bear with me on this one. Oh, here it is now. Okay, so what we have, yeah, I'll copy that. And now we go back into here, put it in, and verify. Okay, so we're in. So now you'll see this screen when you log in. You see free SQL on the left. You see SQL worksheet. The buttons here at the top, this is the run a statement and so forth. You could fool around with them on your own. I'm just going to give you what you have to do. Okay, so the SQL files that you would download, that zip file, it'll contain three files: a create tables, a drop tables, and a tuples. Okay, so I opened them in Notepad. So I just wanted to cover them as well. Drop tables. Okay, so they run drop commands. They were with the homework. We're dealing with three tables. So if you're trying to load the table, something happened, you want to start all over, you would execute this. I'm going to show you how to execute this. I don't have these tables right now, but I want to show you. Okay, so I copied it. So I went into the file and I copied it. So now I go back into here and I'm going to paste it right here and I'm going to do execute. Okay, and that'll drop the tables. Okay. Okay, it's telling me they don't exist because they're not here yet. You would see them on the left. Okay. But that's how we're going to do. We're going to copy and paste into here and hit execute. Okay, so the next file uh, from this is the create tables. And as you can see, here's a create table casting. And here are the fields that are in the table: the movie ID, the actor ID, ordinal. Okay, and here's a primary key, and here's an index. So it'd be good if you want to look through that to understand it, okay? But what you can do is we're going to select all. We're going to do Control C, and then I'm going to go back to Oracle SQL, okay? And I'm going to put it in. So I'm going to highlight that, backspace. Now I'm going to put this in, and we're going to run it. Okay, now you'll see an actor table, a casting table, and a movie table. They don't have any data in them yet. So we're going to do tuples. Now the tuples, as you could see, has inserts. Here's the insert, right? So it inserts all the data. It's quite a bit of data that it's going to insert. So edit. Let's see if this works. I can't remember if I have to put hopefully this works. If not, I know how to edit it to get it to work. I'm trying to remember from last time. So you can go back, hit this, do Control V. Oh no, no. I forgot to copy. Let me go back here. I did a select all, edit, copy. Okay, so now I'm going to come back into my SQL and I go Control V. And now let's see what happens. Okay, as you could see, okay, so it worked. As you could see, you get the actual uh yeah, the actual you'll see it'll tell you insert a row, insert a row. So it went through this file and inserted each row. Okay, nice. And it's 1,700 lines. Now we hit backspace. I'll hit backspace, clear it out. So let's see something. I can't remember. Okay, so what we can do here is if you want to check, right? So you can do select star from actor. Let's run it. And did we get any queries? How come we didn't get? Maybe you need a semicolon. That's interesting. They're in there. Let's see this. Oh, so I think the problem there is you need a semicolon. Semicolon ends the line, and this is just taking a long time. Am I going crazy or what? Oh, maybe. Trying to remember this. So this. Well, how come? I'm not sure. Oh, I think maybe this is why. Maybe it's the case I'm trying to remember from last time. It was a little. Okay, so right now, I don't know why it's not returning anything. The data looks like it's in there. Okay. This thing's sometimes very buggy. Let me do this. Let me sign out. Oh, wait, I have to connect to the database. Okay, see where it says connect to the database? Okay, so let me do this. That's the message it's telling me at the top. Okay. Well, we're lucky we got this far because now they're having a problem with the Oracle. Okay, so I think that's the problem. So that's the best I can do right now. So, okay, what are the odds? It always happens when I give a lecture, right? So, but you could see there that I loaded the data. I did a select statement. You need the semicolon after it, and so you should be good to go there. So I want to go back to the homework. So this is a problem when using online tools. Uh, Sometimes you run into an issue. So I want to go back. No, I want to go back to the homework so we can go over the question. So, uh, no, that's not it. I have it here. No. Okay. So open your browser, go to Live SQL. I did that. Let's see. Let's see if this will work again. No, not working right now. Okay. So, okay. Of course we would have this. I want to go over. So open it, you go there, you create your user ID. Okay, so to end each SQL statement, you either use the forward slash or the semicolon. Okay, don't use the go like I was doing. Just the semicolon after each SQL statement. So there's an example. Select actor ID from actor, semicolon. Or maybe select star from movie, semicolon. So when you get the day loaded, you need to be able to run those select statements uh, to to do that. Okay. Okay, so we did that. I showed that if you need to upload a script, tuples, you can click. Okay, so I wouldn't pay attention to these directions because I had problems with this tool last time I took the course with upload script and I just copied and pasted them right in there and executed them. And they worked fine. Okay, what do you need to do? You need to answer these questions. You need to load those, download those three SQL files, and you'd probably only run two of them, the tuples and the create tables, okay? And so now you got to write SQL queries, and this is what I was talking about. List the titles of all movies. That would be select star from movies, right? Semicolon. And so you go and you uh do each one. And so what I want you in the text file, all I want is this. For example. Okay? And then there'd be two period. What's the next one? So some of these are very simple. List the actor table. So then the next one would be, right? And so that's all I'm just that's all I want you to just put a number and then there's your SQL statement that you use. That's it. I don't want to see the results. I don't want .sql files. I just want to text file that information. So as you can see, a lot of these so just make sure that you pay good attention to the question. Like for example, 4. Uh Okay, number 3, here's a good one. List the actor ID of the actor Kevin Bacon, right? So this is getting more specific. And as you go along, the problems get more harder. List title of all movies, for example, 9. List the titles of all movies that cast actor Kevin Bacon. Okay, so there are 9 questions. Is that true? 9? Okay, so there are 9 questions that you have to answer and pay. This is a good one. List movies that have votes between 3,000 and 4,000. And I want to show you something here. Uh, this is what I would use. See? The SQL between operator. So price between 10 and 20. There's an example. They're selecting all the columns from products where the price is between 10 and 20. So for that problem, I'd use the between uh, operator. And so that's why it's great to refer to this um, site while you're trying to do them. Okay? And so just upload the text file. That's all you have to do, and then we should be good. So I try to keep this lecture as short as possible because I want you to get to it and experiment with SQL. And unfortunately, I had a problem with the website, which happens. So uh, if you have any problems, let me know. If I have to, I'll shoot another short video of me actually successfully executing the SQL statement. Uh, Maybe I'll do that later on in the week. Hopefully this thing should be up soon. I've seen it go down before and it comes up pretty quickly. So there you go. So that's all I had for tonight. Does anyone have any questions before we end the lecture? If not, I'm going to say good night. I hope everyone has a great 2 weeks and you enjoy this. Hopefully that you enjoy this assignment. I would think probably more than the previous assignment. Most students do. Okay. Take care and have a good night.